Hello, Governor. What have we got here? Why, I do believe it's the mighty Megasquirt. Sorry. Anyway, this is a fuel injection ECU for, DIY vehicle engine management. I don't know a lot about it. I think it's fairly simple, probably not used for high performance applications, but certainly if you've got an engine that maybe you want to add fuel injection to, or maybe want to try and get a bit more performance out of a one that already is injected and you want to change everything, or you're maybe doing an engine transplant into another car and you need a different computer. But they've got a few variations of this, and some of them even have CAN bus support, I read. So yeah, they're probably pretty good. I believe they're quite popular among the DIY type users. So yeah, anyway, this one has apparently lost a couple of outputs, so we're going to pop it open and do some checking and see if we can find out what is gone wrong. Now, what you get with these is a very basic wiring diagram, and apparently that's about it. And the lines that we are interested in today are the ones that go to the fuel pump relay. And apparently when you turn your key on, like most cars, the pump will come on briefly and then stop. That's not happening. If the engine cuts out, the pump's also supposed to stop. So say if you have an accident and everything stalls, you don't want it pumping the tank empty all over the place if you've got a split rail, for example. And one of the other lines we're looking at, was actually two there, igniter module drives. No, there's actually three igniter module drives. I didn't see that other one. No spark, no fuel and no spark, so we need to check those. There is a little board that you can make that simulates this being connected to an engine. I don't have that. Would be bloody handy though. But however, we'll do some basic checks inside and see if there's anything obvious. So it looks like 4 screws on each end. There's a map sensor, it looks like there, and that socket's stuck to the panel there. So I'm thinking I'll take the other end off and undo these 4, and this panel will slide off with the connectors attached, and the guts will come with it. Well, I stand corrected. The 2 screws on the top at each end are actually holding a lid on. I thought it was one piece box, and the other 2 screws hold the bottom half on. So there we go. And there she is. So now it's just a matter of tracing out the inputs and outputs, and it looks like I was going to say double-sided board, but it looks like multi-layered board. So this could be a whole lot of fun, but initial inspection, nothing black, nothing smells burnt, and yeah, we can see there's a couple of transistors there, probably drive something. There's some transistors along there, maybe drivers for something as well. Yeah. There's I don't think there's a lot of info as far as I don't know if they've published the circuit diagram for this. It is fairly customizable, I believe. There's an open source firmware. It's written in C, and I'm pretty sure they said that there's a version available that you can write your own settings and modify it to suit. So we've got there what looks like a voltage regulator, and a, what do we got there? transistor of some sort. Well, I guess all there is to do is to trace back to the main port here and figure out where all our drivers are. Okay, so the first one I'm going to look at is the fuel pump relay control, which according to the diagram is pin 37. So if we're looking at pin 37, bottom right corner there, and if we have a look over here on the top side of the board, which is going to be hard to see on camera, but pin 37 comes in, there's a little trace that comes in along here into this transistor here. The center pin of the transistor comes out to that resistor there, so I'm thinking that that may be likely to be the control, the base, and the pin on this side is connected to ground, which makes sense because the relay has positive on one side from the ignition switch, and it just switches the ground on to turn the relay on. So first thing we need to do is check that transistor. There's also a diode hanging off here, which is likely going to be for EMF suppression, elimination, back EMF elimination, so when the relay opens the collapsing field doesn't send hundreds of volts through that little transistor there and destroys its life. Okay, so we'll check that transistor first. Right, so the data sheet for this transistor, which is a P2N2222A, the pinout is collector, base, emitter, and in that order, reading left to right, and it's an NPN. So, knowing that, I can grab my multimeter and diode function, and then we've got emitter, base, collector. So our base to emitter line, we are reading normal 0.6, and base to collector, base to collector was the first one, base to emitter is 1, could be a bit high, and our collector to emitter, checking in both directions of course, so may need to pop that out of circuit just to be sure, but I should have had a half volt drop from the base to emitter, so we'll just check back down the line and see if that other diode attached to it is okay as well. Now that was that one there. And that's okay. And then after that, because that just runs back to some other diodes that I'm not sure where that goes to right away, but so with a multi-layered board, and I've looked at this under a light, and I think it's only two-sided, double-sided, but it's with through-hole plating. Instead of trying to take this off, where you have to unsolder 3 leads, and it can, if you're not careful, it can lead to disaster if you pull the through-hole plating through. If you think about how it's connected up, one of these leads goes to this socket, which is currently connected to nothing, so one lead's already disconnected. The other lead is going to ground, and the base is going to this resistor, and it goes nowhere else. So all we need to do is remove this resistor, and we've isolated 2 of the pins, and effectively that transistor's out of circuit. It doesn't matter that one lead is connected in circuit, because there's no other path back to any other pin that could give us a funny reading. So I'm just going to heat that resistor and lift it out, just lift out one side, and that should give me enough enough isolation that we can test that again and just see if we get the same reading. Okay, so we'll check our base to collector reading, and that looks normal. Then our base to emitter, and that's still looking a little high. I don't like that at all. Now they have used, it looks like, I think the same transistor in quite a few places, so I will check some of them for to see if they test the same, in case it's just that type of transistor. So there's a few along here, so I'm just going to give them a quick check and see what we come up with there. So we've got our base collector, there we go, get that in the frame. So we have our base to collector, we can get a good connection on there, there we are, and base to emitter. See, look at that, 0.6. So that transistor is not very happy at all, and is likely resulting in it not switching on, or not switching on enough, not able to pass current that is required to switch the relay on. So at this stage, I think we can say that transistor needs replacing. What I will also do is just check the base drive resistor that I've pulled up there, and looking at the codes, it looks like it should be about 100 ohms, 1k ohm, sorry, 1k, there we are, 1k. I can, there's some other ones in there, there's quite a lot of coloured bars on these ones, but again, if you're not sure, find another one the same and check that value. It's unlikely that they're all going to be off. There we are, 1k ohm, so the drive is okay, and the diode off there appears to be, that's okay too, so our protection diode is okay. So obviously something's happened that's caused that transistor to fail, and whether it was trying to pass too much current perhaps. There was a mention that the relay that was driving, they actually installed two relays. I would have thought one controlling the other, but it's entirely possible that this poor little transistor has been asked to drive two relays, and it's not really up to supplying that much current. Yeah, we'll call that and find a replacement, and we'll go check the other line for the ignition module feeds. Okay, following through again on our sheet, we're looking for pins number, I'm going to say 27. We'll start with 27. I'm not entirely sure which module, which line they've hooked up, so we may have to look at all of them. But if we go 25, 27 and 29, so counting from the left, 21, 2, 3, 4, 20, yeah, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5. So 25 is our first one. We have to count from the back actually to see where that comes through. Okay, let's just do a test to see where we're at, because we want to, we'll be kind of guessing at the moment. Is that, oh cool. Alright, so we found pin 20, 20, 21, you can see the trace coming off, 22, 23, 24, 25 is actually quite a skinny line, as is 27 and 29, so they're obviously not supplying any great deal of current, it's only a trigger signal, and they run up to, well, there's 3 solder points there, which I believe are these 3 lines here. So they've run bodge wires, as they call them, unplanned modifications to the original circuit generally, because it's much tidier to build in the traces properly. But anyway, over to here, and these points are directly triggered off of the micro. It looks like we've got yeah, they come in. These resistors here go to the micro, and they also go to these transistors. Now, what's going on there? Which we know for a fact that the base is a center pin. These resistors are connected to the base, so they are also driving something else. But what are they driving? It does appear that there's a provision for something else to be added on there. That could actually be a maybe an LED. We have D as the designator, D17, which is unpopulated, so it could be D for diode, with of course that indicating the flat side of the diode. You can see a little white line on there, so it's entirely possible they're planning on, you could possibly put LEDs in to see if the triggers are firing for the ignition module. And then we've got resistors there that would be the current limiting resistor for the diode, because then that goes back to there, which does look like a common line that I'm going to say, without doing any further great amount of research, is probably a power line. Yeah. Okay, so interesting. This is kind of good, because we can see that these three transistors, well, the with the wires going directly off the micro to the outputs there, we know that the micro is controlling the ignition module trigger signals, and that they don't require a large amount of current, and that either means two things. Either it knows that the fuel pump relay is not engaged, whether it has some current sense or something to know that that's switched on and the relay is active, and because of that, it knows that it can when you're cranking the engine, it's got fuel, so it can fire the spark plugs. It might be that the micro is just shutting down that because the fuel pump's not active. Yeah, otherwise, I mean, it might be that the outputs on the micro are damaged, which would be worst case scenario. There was some mention of a lack of a ground, because they actually run a separate igniter box. So, oh, of course, yeah, so that's why it's only signal lines, quite small. It actually goes to I forgot about that, it goes to a separate box that has the igniter coil drivers in it. So, that said, back to what I was saying, it's good to know the circuit design here, because it's unlikely in this application that they are ever going to want to be firing LEDs which are hidden inside, because yeah, there is no holes on the panels for those, although you could have, and that would look kind of cool if you had this thing sitting in a position that was visible while the car was running. So because this transistor is the same transistor that is used here, well, you just pinch one of these because they aren't needed anymore. Simple as that. Easy fix. Instead of trying to find a source of equivalent transistors, why not? Hey, nothing is going to be affected by it. This is driving a hole. It's not driving anything at all, and it's not going to know that those transistors are missing. So I am going to do that, and I think after that, as I have no means to power this up, It's going to need further investigation on the car perhaps. So it's entirely possible that we've got a throttle position sensor input, and we also have crank sensor input. So I'll follow perhaps the crank sensor signal, because it's not going to give spark if it doesn't detect rotation, and that's on pin what have we got there, 24. So if we have a look on here, 20, 1, 2, 3, 4, that comes into there, which goes to yeah, appears to go there. It goes to here. We've got a bodge resistor there. That line runs under those to here, which is a diode there, and kind of awkward when they do that. One side to the other can take a couple of seconds to find yourself, especially when you don't have a decent light. One moment. Welcome back. So the input from the crank angle sensor comes through this diode, through that resistor, through a wire link, and into this little thing here, which is a 4N25, which is an optocoupler. Makes sense. Nice easy way to trigger the micro, and rather than directly firing into the micro, it could be a level thing. The crank sensor may put out a different level than the micro can accept in, or it might just be just for safety, in case, I mean, maybe if you say something goes wrong with your wiring loom and you short your crank signal wire, damage the loom and short it out. Yeah, protection of the micro is a must. So I could be totally wrong. There could be a completely different reason for using the optocoupler, but sounds good. Anyhow, I guess we could do a basic check on the optocoupler. It's got a diode. It's got a diode inside, a light emitting diode, and a photo transistor that's triggered by that. So I believe pin 1 and 2, according to the data sheet, appear to be the diode. Yeah, and what have we got that way? Yeah. Oops. Now we have a 1 volt drop forward bias on there. Now I don't know, this is in circuit again, let's not forget that. Feed diode is okay, and then on the output side, which is pin 6, 4, 5 and 6, so 6 is actually connected to the base, and then that gives us base to what do we got there, base to collector and base to emitter, and collector emitter. That looks good. I'm a little unfamiliar with the forward biasing of a because it's an LED, it's probably, yeah, I'm just going to say it's good. I'm going to say it's good, and we'll throw a scope on it if need be and see what's going on there. But I think once we get this fuel pump sorted, it's going to be so much easier to figure out while it's on the car and running. Yeah, that transistor there's a place to start. I'll check the one beside it too. Down there you can see another one there folded over, just on the off chance. Just I don't even know what that drives yet. I haven't even looked at that. It's possible it drives, looking at its position in the circuit there, relay for the fast idle solenoid. I think that's what that's driving. I don't know if he's got a fast idle solenoid in there, so that's actually giving a funny reading as well, but it is in circuit, but don't like that at all actually. Maybe further testing of that one. I suppose it could be loading the system up if it's yeah, not too flash. First things first, let's get that one out, and the easiest way to do that is going to be, since we know it's faulty and we don't really care about it, as far as overheating goes, I mean this method you want to be kind of quick. Blob solder over all 3 pins. It's the easiest way to get heat into all of them and remove something that's on a multi-layer board. There we go. I would not have expected a lead to fall off with a little bit of heat and a little bit of wiggling, so that's entirely likely that it sustained some kind of physical damage and ruptured somewhere in there. Yeah, the things you find out when you get stuck into it. You know what, I'm going to retract my previous statement on whether it might have current sensing to know that the relay's turned on for the fuel pump before it fires the spark. I'm just going to say that's probably highly unlikely. However, we shall see if this thing runs. But I've got the other transistor out of the unused area, and I'll check that first. It's a good idea to, if you've pulled a part out that you want to reuse, just to check it, make sure it didn't suffer through the extraction. And that's looking good. That's looking good, and that's looking good. So yeah, I mean, you know, in case you happen to have too much heat on it for too long, it doesn't help that when they put these through, they fold the legs over so that they're kinked right on the board, and when you're trying to pull them through, of course, they catch all the way through the hole. Yeah, but they came out nice and cleanly, and the trick is to have enough heat, because you don't want the solder to be not to be fully melted. I was using 315 degrees C in this instance. It was at 290, but it wasn't quite enough, so I bumped it up to 315. Much better. And the transistor is now being transplanted from here to here. Resistor, base resistor reinserted, tested, all okay. So part 2 is where I find out if it works in the car and find out what else might be going wrong. Yeah, as far as the lack of coil firing goes, need to obviously take a closer look at the wiring in the car, and possibly need a scope to watch for the pulses off the crank signal, crank position sensor, and make sure it's getting through to the micro. But other than that, I don't see any reason to believe that the micro's been damaged, so yeah, stay tuned.